So please welcome Ivan.
Thank you. I have 30 slides. They gave me 25 minutes. So I'll skip most of the stuff on the slides. It's there just for your reference when you get the presentation afterwards. I'll skip this one. The important part is at the bottom. I built too many labs in my lifetime. I hate building labs. So when I get a question like this one, and it's based on a true question I got on my blog, I was talking about unnumbered interfaces. You know that idea when you have the interface addresses being equal to the loopback IP address. So you save address space, and you're running OSPF on that. And someone was, pontificating whether, oh, I wonder what would happen and whether that is vendor specific and yada, 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 yada. And like, dude, did you even think about trying this out in a lab? Because, this should be trivial. And then I remembered that labbing in the old days was like this. And do you really want to go there and set this up just to test that one feature? Nope. Today, we are lucky because everything is virtual, and we get things like that. That's GNS, sorry, that's CML from Cisco, but you have GNS3, you have EVNG, you have tons of open source things that allow you to run the virtual machines and build a lab with your mouse. And then at the end, when you're done clicking and dragging cables across that screen and you start things up, you still haven't done anything because you've solved the first part of this puzzle. You have the topology, and then you have to type in the IP addresses, and then you get them wrong, and then you have the subnet mismatches. And then you have to type in the BGP neighbors, and you get them wrong because you forgot the IP addresses, and they don't come up. And then you're like, oh, 3 hours later, I have a running lab. By that time, I'm in this stage. I'll have a beer. And now imagine in the land of unicorns. Or as they call it, infrastructure as code. Or maybe if I would be working for a vendor, it would be intent-driven. So my intent is to have a lab with 2 nodes, R1 and R2, and on the right-hand side is the actual topology file that my tool is processing. And well, we'll make them Arista containers, which means that the default device will be EOS and the provider will be Container Lab. And oh, they're running OSPF, so we are bringing in the OSPF config module, and that module does all the magic. And we need 2 links between them, so we'll have links between R1 and R2 twice. And we want to have some stub links so that we get the IP prefixes. And so those are the links. And oh, by the way, they're unnumbered, so the addressing on point-to-point links for IPv4 will not be a prefix. True means unnumbered. False means don't use. And then you save the file, you execute one single command, and you get a running lab. I'm not crazy enough to do a demo, so this is a video, but it is in real time. It's not speeded up. The one thing we're waiting for is for Arista to start. FRR starts way faster, but Arista has a lot of things to do. I don't blame them, they're fast. So first, it created the container lab topology file and the Ansible stuff. Then it started the containers, and now we are running an Ansible playbook that builds the configurations and deploys the configurations. First, the initial configurations, and then OSPF configurations. And it's done. The lab is up and running. This is real time. So I connect to it. Now I had to cut for 30 seconds for OSPF to set up the adjacencies. And I can do show IP OSPF neighbors. You can see they're up. I can do show IP route. There's the answer. So that guy could have produced his answer in literally 1 minute after spending half a day installing the tool. This is what's going on behind the scenes. So we had to supply the topology file. Then the tool, we've been working on this tool now for like 3 or 4 years. So it's pretty feature-rich. It does the data model transformation from the high-level intent, in double quotes, to the device data model. So I'm running OSPF on this interface, and I have an IPv4 address on this interface. And then we are using the configuration templates for different devices to translate this into device configs. So you can do the same lab with Arista, and tomorrow you do it with Nexus OS, and the day after you do it with Nokia SROS, and the day after you do it with SR Linux, the day after you do it with Junos. We handle the configs. You tell us what you want to have, and we do it. Oh, you can also mix it. One Arista, one Junos box, one XR box, you name it. We are using two tools to prepare the virtual infrastructure and start the workload. It's Vagrant with KVM and libvirt, or Container Lab for Docker containers. So we can take virtual machines or containers. And the most important thing is we do all the heavy lifting for you. So you want to check, let's say, whether BGP add path functionality works with Arista. Oh, you need addressing, you need the interfaces, you need OSPF, you need BGP neighbors, you need all that. Oh, we do all that. You just add the one command you want to test. So instead of wasting 3 hours setting things up, plus 5 minutes figuring out whether it works, you skip the first 3 hours. And as you can see, we do pretty much everything apart from IP multicast. I hate multicast. Of course, we know that every network is special, so you can have custom configuration templates. So if you always use the same thing, you can just build a template, and that thing gets deployed on top of what we deploy. So you are at the stage where you want to be. Or we have plugins. These are Python modules that can do anything. So for example, once I wanted to have IP anycast functionality, where multiple routers would advertise the same loopback IP address from the same autonomous system, so the AS path would be the same. And then my tool would go like, oh, you are in the same autonomous system. I will set up iBGP between you, because that's how we do things, right? Well, not in this case. So I wanted to have this plugin that would cut off the iBGP sessions after the transformation is done. And it's online. It's in the GitHub repo, so you can go and check it out. This is the current state of the tool as of 1 month ago. We added a few things in the meantime. The platforms that we support, we ran out of ideas. So there is one vendor missing on this that's pretty popular in some places. Starts with H. The only reason it's missing is not because I hate them or anything. They don't have an easily downloadable virtual machine. So if you don't care, I don't care. Thank you. Apart from that, more or less everything you could ever dream of. Plus, we do have some generic daemons like BERT and DNS daemon. If someone wants to bring some other routing daemon, talk to me. KVM and Docker are supported. We did support VirtualBox, but no one was using it, so we stopped doing that. Or you can configure hardware labs if you wish, in which case the only extra thing you have to specify is, well, the actual wiring plus the interface names. For the virtual labs, we know what the interface names will be. Oh, we even insert bogus interfaces to the virtual machine so that you can get the interface names right. So if you want to have Ethernet 1 and Ethernet 2 and Ethernet 5, we will silently insert 3 and 4 so that the numbering works out. And the last thing, you can combine containers and virtual machines in one lab. So you would do FR routing in containers and Arista in containers, and then you can add a Nexus OS virtual machine to that. You could do everything in virtual machines, but then it would be way slower and use more resources. On the addressing front, we do everything and everything else and some more. So we automatically assign addresses, or you can do static addresses, or you can change the pools we assign from, or you can do unnumbered, or whatever. On the data plane, we do VLANs, VRFs, VXLAN, MPLS, segment routing, both variants, and tunnel interfaces. On the routing front, we can configure all major routing protocols, plus static routes, plus the new thing this month is discard static routes, a route redistribution between anything and anything with route policies or not, the route maps, the prefix filters, the AS path filters. I was bored one day, and I just wrote that stuff. And then other people implemented that on like 10 different platforms. So you can now do route maps on Cisco, Arista, FR Routing, Junos, a few other platforms. Anycast gateway if you want them, or VRRP. In the MPLS, we do LDP, BGP-LU, we do L3 VPNs, we do 6PE, we do SRMPLS. Oh, by the way, L3 VPN, you can do it over MPLS, or you can do it over VXLAN with EVPN, or you can do it with SRv6. And in EVPN, because we have a crazy contributor, we support all the crazy stuff that the vendors are selling. So you can run iBGP and OSPF, or ISIS, like the same people. Or you can go eBGP only, or you can go iBGP over eBGP, like one particular vendor is recommending. And you can test in multi-vendor environment how these things work together. And surprisingly, they work. I was so surprised. This is an old snapshot of the documentation, so you can see a little glimpse into what's supported. The whole documentation would be like an hour-long presentation. If you want to connect to the outside world, we support the ways to connect the virtual machines or the containers to the outside world. So you can even connect your virtual network to an actual outside BGP feed, for example. You can connect this to your exchange point and take the BGP feed from the exchange point if you wish. And it's really easy to start external tools. If an external tool is in a container, you just tell us how that container is started. And we can create volumes and all that. And then that container is started immediately after the lab is started. And if you tell us how to build the config file for the tool, we do that. So we integrate it with SUSIQ. That's an observability platform. Graphite is a user interface. So you can point and click on your routers if you prefer that instead of opening terminal sessions. EdgeShark is a beautiful thing that does capturing on a Linux server and then transports captured packet over HTTP to your laptop, where it creates a virtual interface that you connect Wireshark on the laptop to. So you're running everything in a Linux server somewhere. I'm running it at home. And you can capture on your laptop, sitting in a coffee shop somewhere. Someone did Cisco NSO. Then you can create reports. You can create graphs. We don't do graphs. There are tons of tools on the market, open source, that do graphs. So we just create the graph description file, and then you use that one tool, and it creates a beautiful picture of your network. Automated validation. So you can write tests that are executed whenever you wish. So you can, I'm using that in the exercises for BGP, for example, that I wrote. This is your exercise. This is what you have to do. And instead of logging into devices and doing show commands, you just run a script, and it validates whether you did everything that you were supposed to do. Plus, if your server has too much memory, you can run multiple lab instances on the same server. Some software development companies do that because all developers share the same server with the same images, and everyone is running their own labs for software development purposes. We even had to implement a staggered device start for someone, because if you start 50 virtual machines at the same time, everything collapses. They all burn 4 CPUs when you start, so you never have 200 cores. But they burn maybe half a CPU when they're idle. So if you start 10 at a time and wait, and then you start 10 more and wait, and then you start 10 more, you can easily start a lab with 50 or 60 network devices. And I'll show you a topology at the end, what someone did, and was like mind-blowing. All right, what do you need to deploy this stuff? Well, today we are recommending that you're running this on a Linux machine. It can be a physical server. For example, I bought for myself this small brick for €1,000 with 8 AMD Ryzen cores and 64 gig of memory. You just mail order it, it arrives. You have to install Python on it. We're recommending Ubuntu, although people are running this on all sorts of Linux distros. But if you come along saying it doesn't work on, I don't know, some X distro, we can't help you. If you're saying it doesn't work on Ubuntu, then it's my problem. You have to install this other software. It's all open source, and it's all free. So the cost to get this up and running is just the hardware cost. If you want to run this on your laptop, then with Windows, today you have the Linux subsystem for Windows. It works on that. On Mac, you use the from the canonical, the multipass. It starts a Ubuntu virtual machine on the Mac, so you can run the labs on your laptop. Anyone using Mac with Apple Silicon? It works. You're limited in what you can run in this virtual machine because it's an ARM CPU, and an x86 virtual machine will not run on an ARM CPU. But Arista has an ARM container, SR Linux has an ARM container, and FR routing is open source anyway. So you can run 3 different devices on your Apple laptop, which is good enough to test complex things like maybe VXLAN with EVPN. For everything else, you have to register somewhere and download something, and then you get a virtual machine that boots and expects you to type on the console port. That's not good. So you have to get past that stage. You have to get to a point where the virtual machine has DHCP on one interface and an SSH server enabled, and then we can take over. So you have to build the Vagrant boxes. And getting the stuff is as easy as no hassle for Nokia, SR Linux, and BIOS, to little hassle for Juniper, to reasonable hassle like Arista, Aruba, Cisco, and Cumulus, to, oh, you have to beg, or, oh, you have to know a developer who might give you something. OK. And then you still have to write that config file, which brings me to another unicorn as a service. Because no presentation would be complete without mentioning AI these days. So you can vibe code your way to netlab topology file. I actually tested this prompt, and it works better if you include the URLs to give ChatGPT references to where the documentation and examples are. And it generates something, and of course, it's wrong. And then you save that into topology file, and you start the lab, and the tool complains, and you copy-paste the error messages back to ChatGPT, and 5 iterations later, you have something suboptimal. But amazingly, it works. It was able to generate the topology file with 2 routers and 2 links running OSPF. How cool is that? On a more serious note, we have hundreds of different examples. It's all on GitHub. So you just go and browse and find something that is pretty close to what you need, and you go from there. If that doesn't work, you just open a discussion and we'll help you out. Back to reality. What do people think about this? Well, getting started is an interesting problem for most people because it requires some significant investment into tooling and building the environment up. But once people start using it, it's like there's no going back. So people who invested time and started using it were pretty enthusiastic. And this is the biggest topology I've seen so far. This guide needed the staggered device start. So it's a mixture also of different vendors. So there was Juniper, Cisco, Arista, Cisco both routers, and Nexus OS in there. And the blue boxes are the routers, and the edge boxes, I think, are the Linux hosts they need for the workload. The other thing I'm doing is I'm using this to build lab exercises. Is this starting or? OK, good. So I built a number of BGP lab exercises. And the beauty is that you can run them in GitHub code spaces. It's a free service. You're limited to 30 hours per month. And you get 2 CPUs and 4 gig of memory. You start the thing. It's all in browser, although there's a plugin for Visual Studio Code if someone wants to do that. And here I have the lab exercises. This is tied to BGP. The README for the lab exercise. OK, so that's boring stuff. You don't want to see that. The beauty is once we start the whole thing, so these are the instructions saying change to this directory, we're already there, and then do netlab up. This is running on some container somewhere free of charge. As long as you can fit this into 2 CPUs and 4 gig of RAM, you're good. And the lab has started, and now you can connect to the devices and start working on it. Right. So if you like it, here are a few things you can do to help this. So this is totally free, open source, community-driven. Everything is on GitHub. No hooks attached. The one hook is that eventually I will ask you to upload the usage statistics. It will not be enforced. You will be prompted. You could do it or not. But I would love to know what people are doing and what modules and what devices they're using. Even if you don't want to use it, spread the word. It doesn't hurt. Thank you. Use the tool, ask questions. You can always fix documentation. You can always write a blog post. You can always find bugs and report them. You can always fix bugs. Or you can add new functionality. So if anyone wants to write a Babel module, I think Babel is running on FR routing, so you can do that. Or if anyone wants to tackle IP multicast, you're most welcome. OSPF areas are gone. We just did it last week. All right, documentation is online. I write a number of blog posts going into specific details and hints and guidelines. The source code is online. All the examples are online. Plus, there are 200 more integration tests. So if you don't find something in those examples, you go to the integration test. You might find it there. 2 projects I did with this were the BGP labs and the ISIS labs. Yet again, no strings attached, all open source, all on GitHub. Use it. To reach me, these are the coordinates. If you want to discuss something, if you want to report bugs or something like that, I would appreciate if you could go to GitHub and open a discussion or an issue so that it's tracked and archived. But obviously, if you want to send me an email, there's my email. And now I guess I'm totally out of time, which means that find me somewhere during the break and you can ask me whatever you wish.
No,
Thank you.
We actually do have time for a couple of questions. Oh, and there's one back there. You made me walk all the way to the front to then come back. There you go.
One question I probably didn't. Sylvan from Open Factory. One question, is there plans for support for VSLX? I don't think I've seen that. Because this country is a extreme country in some of the things I've seen.
VSRX like Juno's stuff?
SLX, as in extreme networks.
Oh, okay. Do they have a virtual machine that you can download? Talk to me.
Okay.
By the way, you're always welcome to submit a PR. But yeah, I would love to have that.
Okay, another question. I think. Oh, sorry, Martin Winter with FR Routing.
Yeah, we've met.
So, question first is like I think you just forgot to mention it, but I assume you have a generic switch device in there too, which you can add.
Yes and no. So we do two things. One, if you connect three things together, we would use a Linux bridge between them. So we would emulate a thick coax cable with a Linux bridge. Or you can say, I want to emulate this multi-access segment with a bridge device. And then you can specify what device you want to use for that bridge. And that device has to have VLAN implementation so that we can actually turn on layer 2 switching. And then you can use anything you wish as that generic switch device. It can be Linux running in a container. It can be FR routing, although you don't need FR routing for the control plane because it's just layer 2, but you know, it's nicely packaged. Or if someone wants to use, I don't know, a Cisco layer 2 image or an Arista image for that switch, they can do that.
Okay, so the other question is, do you have any options in there for route simulations if I want to inject like 10,000 BGP routes?
Oh, yeah, there's a blog post written how you use this with BGP pipe. So you use some external tool that, you know, we are like Linux. We give you the infrastructure and then you get creative. So there are tools that can insert BGP routes like BGP pipe. And you just start a Linux node with the image that is BGP pipe. And then you configure that stuff and you get whatever you wish into it. But yeah, maybe I should make... talk to me.
Yep. think this is something for the break later.
Yeah.
So, thank you very much.
Thank you.